Okay. Welcome, everybody. I'm Radomir Dopieralski, and I'm going to talk about making computer games with MicroPython. I have to start with a disclaimer. So I'm not getting paid for this. This is not my job. All my opinions are my own opinions, not of my employer or any organization I might be a part of or anything like that. However, I didn't do all of this myself. I did receive a lot of help from a lot of people, mostly from the MicroPython community, from the Adafruit community, from companies like Adafruit or Oshpark and so on. So that's not just my own work I'm showing here. This is not an advertisement of any of those companies, and they don't pay me for advertising them, just to make it clear. However, I do sell my stuff on Tindy. This is like Etsy for electronics. And I'm not also, obviously I'm showing my stuff here, but it's not with the intention to advertise it for selling. I'm not earning money from those sales. So it's just to make it available for people out there. I do receive free stuff from various electronics companies to try because they like the things I do and they would like me to write reviews or whatever. I'm not advertising them here. And yes, and I do realize that I'm extremely privileged to be able to do all this, to be able to afford, to be able to have free time for that, and that not everyone who could do that can do that. So I do try to make it easier for others to start with this. So that out of the way, we can talk about the topic. So the main goal, the main idea in here is to take one of those development boards that you can buy now, like maybe Arduino, maybe something else, connect one of those cheap display modules you can get for them, and a bunch of buttons, and make a game console out of that. Preferably handheld game console, because I don't own a TV, so that complicates regular game consoles. And obviously the easiest way to do this is to just take a Raspberry Pi, install like a RetroPie on it, and you are done. However, there are a number of downsides that I don't like about this approach. Obviously, I have tried that. I did a handheld game console with a Raspberry Pi on it. And the first problem is the battery life is not so great, because Raspberry Pi is a full Linux computer, basically. It takes quite a lot of power. The boot time is not that great either, because it takes even several minutes to boot, depending on how it is configured and so on. You'll get a lot of games you can play because there are a lot of game emulators on that platform. However, most of the games you play are actually pirated ROM files. Sure, it's abandonware and so on, but what I wanted to do is to write my own games, and that's kind of difficult when you have such a huge pile of much better games that you can play instead. So I wanted a platform that doesn't yet have any games on it, so I can make my own games for it. Next thing is it's very easy to break it. There are a lot of files in there. There is an SD card that doesn't like when you shut down the Raspberry Pi forcefully, and so on. It's very easy to corrupt the file system, so I didn't like that. It's not that easy to program games in Python in the first place, because the libraries are not that great. There is Pygame, which is basically like 90s style pixel pushing library. There is Piglet, or there is PyOpenGL for 3D, but it's not really very convenient to install and use. And finally, doing all this stuff, basically everything is already done for you. You just have to install and configure things, and that's not what's interesting to me. I like to program and I like to build things. So I really feel like, this bearded Unix guy who just configures everything, and it feels more like system administrator work than a programmer work. And finally, even though Raspberry Pi is extremely cheap, once you have to buy all the stuff for it, the display, the SD card, everything, it comes out, it sums up to quite a bit of money to actually do it. So it's too expensive to do it, say, as a workshop with 20 people where everyone has their own. So, MicroPython. What is MicroPython? MicroPython is an implementation of a language similar to Python, basically with the same syntax as Python, but a little bit different internals, that runs directly on microcontrollers. So no operating system, it's like BASIC on ZX Spectrum or on Commodore 64. Basically, your program owns the platform. There is no operating system, you can do anything. And the first platform for which MicroPython was released was a custom board called PyBoard. There is a table in the first building where all the hardware is, where they are showing the PyBoard and the new version of PyBoard and so on. And that was an STM32 based board with quite a lot of computing power and memory. However, it was quite expensive. At least at the time when I was starting with this, that was too expensive for me. I did buy one, but I still have it in my drawer because it was too precious to actually use in any project. So sometime later, came out this Kickstarter for MicroPython to actually port it to this very cheap Chinese ESP8266 platform. There are a lot of development boards with that, and that really encouraged me to actually try and start making my dream game console using Python. And yeah, so what I needed, I needed all this stuff that I listed here. I will come back to this slide as I explain it. So first, SPI, HSPI, so hardware SPI. What's SPI? SPI is like a serial protocol that's commonly used in electronics to communicate between two different chips. It's similar to I2C, but it's usually much faster. And the main idea is that you have a data pin and you have a clock pin, and you set the value that you want to send on the data pin, and then you wiggle, like change the clock pin to tell the other side to, at this moment you can read the value of the data pin. If you didn't have this clock pin, they wouldn't know how fast they should read. Like when you had 3 zeros in a row, they wouldn't know if it's 3 zeros or 1 zero or 2 zeros. So when you have a clock pin, they know that every time the clock changes, they have to read one new value from it. And there are some additional pins in there to tell them that now you should listen, that this is data and not command, or command and not data, and so on. All in all, you need about 4 data pins to communicate with the other device. You would need 5 if you needed communication in the other direction as well. However, we are only going to send data to the display. We are not going to listen what display is telling us. So we only need 4. And of course, we need power. That is not included in here. So the thing is, many microcontrollers have already this protocol implemented in hardware. They have a separate peripheral on them that lets you talk this protocol very fast. Like in case of the ESP8266, it's 80 megahertz. The clock rate is 80 megahertz. That means you can send 80 million bits per second, which is quite nice, especially if you are trying to play graphics on like display high frame rate video. The problem is ESP8266, that port that was just being made back then, didn't have support for, the chip has the peripheral, but MicroPython didn't have support for this. And I really needed it. So I sat down and looked at the Node MCU, which is a Lua-based firmware for the same platform that had support for it. And basically, I stole all the C code from there, copied it to MicroPython, and got it to work, which is, for me, quite an achievement because it was the first C project I did in like 20 years after the university. So it was an adventure. But yay, we have working communication with a display. That's great. Next thing, you need buttons. The common modules you can buy for the ESP8266 only have a few GPIO pins broken out. So you can only connect very few things to it. And as you saw, you already need 4 pins for the display. So you only are left with very few pins for the buttons. So I made this breakout board that only has buttons on one side, and on the other side it has a very small microcontroller that takes the buttons all the time and communicates with the main microcontroller through I2C protocol, which only needs 2 pins, the clock and the data. So you can read the status of the buttons quite easily. This is not, well, there are several other ways you could do buttons on a device like that. This is just one of the solutions I made. And I also included a socket for the display module on it for convenience. So you can just plug the display module in there. There is a slight problem. You can see it clashes with one of the buttons, but you can just cut out that corner and it works. There are no traces on that corner, so you can just adjust it. Okay, next thing. Sorry. Yeah, moving. I decided I will not play with sound at that moment. This is just a prototype. Sound is too complicated. We can skip that. Next thing is the frame buffer. So the way those displays represent pixels on them, they have several modes. So you are probably familiar with the 24-bit mode of color, where you have 3 bytes for the color, and each byte is one of the components, red, green, and blue. So this is what you use when you are doing web development and you specify the color in hex, basically. So this display has that. However, we want to be able to send our image data in as little bits as possible. So we instead use the 16-bit color, which is called 565 RGB, because you have 5 bits for red, 6 bits for green, and 5 bits for blue. The reason why green gets 1 more bit is because we have it, and because people are sensitive to green colors more. So we get better quality this way. Okay, so the next thing is the frame buff. So most, actually all libraries that work on MicroPython right now for displays work in this way that they keep in the memory of the microcontroller, they keep a copy of the image on the display. And what you do is you just use SPI.write to send all of that at once to the display every time you change something. This has an advantage that if you modify several pixels and they overlap, you don't send several modifications to the display. On the other hand, this is a lot of RAM, so the microcontrollers don't really have a lot of RAM. So you want to save as much RAM as possible. And yeah, and you are sending the whole frame every time. So that's 52 kilobytes of RAM if your display is just like 128 by 128. That's too big for us, basically. So what we can do? We can use a palette, which basically means we have an index of 2 bytes per color. But in our image, we only use 4 bits for every pixel, and then we can use 16 colors for every pixels and just replace it with the color from the palette when we are displaying it. The problem is the MicroPython's framebuffer module that we have here doesn't have support for that. It also doesn't have support for transparency, which will become important for us in a moment. So what we want to do instead, so one thing is that we want to use a palette for our images. The second thing is we don't want to keep in the memory all the pixels of our display. Instead, we only want to have a tile map. So basically, we will keep all the actual graphics in an additional memory, in the flash memory on the chip, which is programmed when we flash our program to it. And we will only keep like an array of squares on the display, and each square can display like 16 by 16 image on it. Most older computer games actually do the maps in that way, so that that's compatible with what we want to do. And this lets us save a lot of memory because we only store 1 byte per, or even 4 bits per a big square of the display, and all the graphics are actually saved on the flash memory, which we have a lot of. And when we actually send the data to the display, we just make a small buffer the size of one of those tiles. We fill it with already converted colors and so on, and we only send that small area. We only update the area that actually changed. Next thing is we also want to have sprites. So we want to have small pieces of graphics that can move around the screen independently of the tiles. Unless we only want to make games like chess or something like that, where you don't need that. But when you actually want like interactive games where you move around, you need those sprites which are representing like missiles or enemies or the player character and so on. So the way you do it, you only store information about the position in your memory. And once you make this buffer to send to the display, you just draw on top of that the graphics from your flash to show the sprite. And here you need transparency because most of the sprites are not really square. So you need, they have different shapes, so you need transparency. And once you have transparency, you can also have several layers of the tile map. So you can have like parallax effect, or you can have like trees on top of ground and things like that. So this is a tech demo of this actually working. And you get the red balls are sprites, the checkered background are tiles, and the text are actually also tiles. So that's basically the overview of what I wanted to do. The problem I had is the development of MicroPython was at the time focusing on other things. And while I did get some of the features that I needed in there, those are the ones that have check marks, there is a lot of things I'm missing in there. So I decided, okay, let's stop with that. Let's get some, vacation from that, and let's try something simpler. So I started to work with CircuitPython. CircuitPython is a fork of MicroPython that takes the base that is MicroPython, but tries to make it more friendly for beginners. Basically, it's made by Adafruit, who sells electronic modules for beginners, and they really want to have it beginner friendly. So one thing when it started at least, and right now it's also true, I think, they are very friendly for contributors. So it was very easy to get all the stuff I needed in there. But I started with something simpler. It looks like this, and I can actually show you a working version of that. So it looks like this. Where is the switch? Here is the switch. Okay, it's too bright. It's a shame you can see it because it's too bright. No matter. And now I need to switch back to my presentation. Okay, so as you can see, I made a lot of prototypes. The idea is that you have a device that you connect to your computer. It doesn't require any drivers. It just shows as a USB drive. You can see all the files in there. You can just edit them. And you have the interactive console, of course, as well. I started making them as shields for the Adafruit things. And later, because that was too expensive, I made a standalone device, and I optimized it for cost. So this thing costs $10 to make, a single one. So I'm going to make workshops with that in the near future, maybe in half a year or something like that. Yeah, I also experimented with microbit, and I also came back to my experiments with graphics and sprites, and but the time is running low, so I will only show you the photos I have of that, and you can catch me outside this room after the talk if you want to see more and talk about this, and if you are interested. Oh, by the way, I ported it back to MicroPython, but I didn't make a pull request. There is a separate repo. But you can make your own game console with MicroPython yourself. It works on M5 stack as well, and yeah, you can just connect a bunch of wires and a display, and it just works. And those are all the addresses you might find useful. And are there any questions? Do we have time for questions? 3 questions.
I do have one super.
Yes, please.
Do you prefer playing games or programming them?
I prefer programming games. It shows, right? Sorry, the question was if I prefer playing games or programming games. Yes?
What is the thing that you're wearing?
That's a basically bigger version of what is the thing I'm wearing. Yes, sorry. This is a bigger version of this, so you can actually use it as a conference badge or something like that. You can program it to display text and also games or things like that. Yes? Do I have any repositories or open source or examples of the games? Yes, there are the 2 URLs at the top are main URLs to the documentation, and they also contain links to the repositories. Everything I'm doing here is open source. Everything is in the open. Also, the hackaday.io link in the middle there is a link to basically all my projects on Hackaday. So you can, it's like a blog basically. I just put all the updates on my projects in there. Thank you. Thank you very much.
Excellent.
I'm going to need to talk to you.
Nice talk.
I want to make the workshop with that on EuroPython.
I wanted to ask.
However, the problem is people have to have some way of paying for them.
Yes, well, they can bring cash, right?
Yeah, that's one way.
But how can you get, or we could set up something in the shop maybe.
Yeah, well, we will see. I need to vacate the premises.
Mogę ten zestaw kupić?
Za moment porozmawiamy, dobrze? Sorry?
Another game for you. It's not a game, but I ported to MicroPython. I'm interested in history of computing, and I built